Hi everyone, in this lesson we're going to be looking at modeling with trigonometric functions. And first we have some vocabulary. The graphs of sine and cosine are what we call sinusoidal functions. When you write a sine or cosine function for a sinusoid, you need to find the values of a, b, c, and d. A vertical shift, the center of a sinusoid, can be found by taking the maximum value plus the minimum value and dividing by 2. Or if we have a sketch of our curve, we can just find the center. The amplitude, the distance from the center of a sinusoid, can be found by taking the max minus the min divided by 2, or again, just looking at a sketch and determining what's the distance from the center of the curve. So here's a real-world example, and this is a really common problem when we're talking about modeling with trigonometric functions. You're often going to see Ferris wheel problems, which is kind of fun. So we have a rider's seat, all right, their height is mapped to the revolution of a Ferris wheel. And what we'll do is we'll use the cosine curve to model what's happening with height over time with the Ferris wheel. So if you get on the Ferris wheel, you're going to get on the Ferris wheel right at the bottom here. That's usually, I don't know, maybe 5 to 7 feet, somewhere in there above the ground. So we're going to start low on our Ferris wheel. And then over time, as the Ferris wheel moves along, the height of the rider is getting higher. So you can see the cosine curve is perfect to model this. We start low and we get to the top of the Ferris wheel, and then our height starts to decrease again. Now, the cosine curve, the parent function of the cosine curve, y equals the cosine of x, that curve, as you know, starts at a maximum, it goes to a 0, and then it goes to a minimum, a 0, and back to a maximum. So what we need to do is we need to write the cosine curve with a negative out front to reflect it over the x-axis. So Ferris wheel problems are always modeled by the cosine curve where a is less than 0, right? Because the curve has to be reflected over the x-axis in order to start low and have our height rise to the peak. And there's never going to be a phase shift when we're talking about Ferris wheel problems. So we have no plus or minus value inside the parentheses with t, which represents time in this case. All right, so let's look at some examples. Suppose you and a friend are the last 2 people seated on a Ferris wheel that has a diameter of 40 meters. Once the ride begins, the wheel moves at a constant speed. It takes 36 seconds to complete 1 revolution. Use the diagram below. So we're going to write a cosine function to model this situation, and we have some of it sketched out. I'm just going to add a little bit here. So this is the center of our graph. We know that the diameter is 40, so we know that the radius is 20. We start at a value right here. We're 5 feet above the ground when we start, so we start at a minimum value of 5. And then if we add 5 plus 40, we're going to end up with 45 as the value at the top of the Ferris wheel. So the peak height of the Ferris wheel is 45. All right, so just those simple little markings are really going to help make a difference. One other thing I want to point out is that they said it takes 36 seconds to complete 1 revolution. So we know that our period is 36 seconds. That's how long it takes to complete 1 cycle of the Ferris wheel, or 1 revolution. So we want to know the value of A. We know that the A is always the distance from the center, and we have it clearly marked here that the distance from the center is 20. It's our radius of 20. And if you weren't sure, you could use the formula, which is max minus min divided by 2. Our maximum value is 45. Our minimum is 5 divided by 2. That gives us 40 divided by 2. That gives us 20. the value of b can be determined by using the information we have on period. So the period of a cosine curve is 2 pi over b. And we know that our period is 36 seconds. So I'm going to make 36 a fraction, and now I'm going to cross multiply. So I have 1 times 2 pi equals 36 times b. And now I'm going to solve for b. So divide both sides by 36. And we get b is equal to 2 pi over 36. And if we simplify that, we get pi over 18. All right, so far so good. So we know a is 20, we know that b is pi over 18. The next value we're looking for is the value of c, and we said that in all Ferris wheel problems, c is always going to be 0. So that's an easy one. That's a gift question. C. The last one is d. D is the vertical translation, the center of our curve, and we can just look at our picture here, and we know that our center happens right here, 20 plus 5, so our center happens right at 25. You could also use the formula we talked about on the page before, the max plus the min divided by 2. We get 50 divided by 2, which gives us 25. And now we have the easy part of just filling in the formula. So h of t is equal to a. Now remember, we're talking about a cosine curve that starts low and goes high, so we know that the value out front has to be negative. The value we found for a is 20. We have the cosine. B we found to be pi over 18 of t plus d, which is 25. So final answer for part A, right here. At 0 seconds when the ride starts, how high above the ground are you? So what we want to do is we want to put the value of 0 into the function that we just found. So we're going to go ahead and put this function into our calculator, and you want to make sure you're in radians. I can see at the top of my calculator it says radians. If yours doesn't have that, you can just go to mode. You want to make sure that radians is highlighted, select enter, second mode to quit, and now you can go ahead and type in your function. So I'm going to store the value of 0 into x. So I'm going to type 0, the store button, and x, and now I'll type out my function. And I get a value of 5. Part C is asking how high are you after 9 seconds, 18 seconds, and 27 seconds. So we're going to go back to our calculator and look at the values for 9, 18, and 27. I'm going to do 9 store x. And I don't want to retype that, so I'm going to use the repeat the entry command. So I'm going to do second, enter, second, enter. And so the output value for 9 is 25. Now I'll put in 18. So 18 store x, second, enter, I get 45. And the last one, I'm going to store 27, store x, second, enter, enter. And I get 25. How high are you at 126 seconds? And how many revolutions have you made at that point? So again, we'll go back to the calculator and we'll put in 126. 126, store into x, second, enter, and I get 45. How many revolutions have you made? So we have 126 seconds total, and one revolution takes 36 seconds, so we just need to divide 126 by 36. We get 3.5 revolutions. So that means we know that we've gone around the Ferris wheel 3.5 times. So it makes sense. So we go 1, we go 2, we go 3, and then we go halfway around, which means we end up at the top, and we have our maximum value here, so we know we did the math right. We're just using common sense now to just check it. Letter E says, sketch the graph showing the relationship between height above the ground and the time since the ride began, and we're going to look at the values of time from 0 to 144. So we're going to have time here. Time is in seconds. And our vertical axis is height. We're looking at it from 0 to 144. So for each cycle, we need 5 tick marks. This is the cosine curve. So we have 1, 2, 3, 4, 5. That's the first cycle. Then 1, 2, 3, 4, 5. 36 plus 36 is 72. 1, 2, 3, 4, 5. 36 plus 72 is 108. And 1, 2, 3, 4, 5. 36 plus 108 is 144. Our Ferris wheel center happens at the value of 25. I'm going to do a dashed line just to represent that center. The distance from the center we know is 20. The maximum happens at 45. Do a dashed line as a guideline for me where the top of my curve will be. And 25 minus 20 is 5. That's the minimum value of the height of the Ferris wheel. And we'll again do a dashed line to represent that minimum value. And now we're going to go ahead and plot our points, remembering that we have a negative a value, so we're starting at a minimum. So our curve pattern is going to go minimum, 0, max, 0, minimum. 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 And we'll sketch the curve. All right, that's it for letter E. For a person at rest, the velocity of airflow during a respiratory cycle, that means the time from the beginning of one breath to the beginning of the next, is given by the following sine function, where t represents time in seconds. Inhalation occurs when v is greater than 0. Exhalation occurs when v is less than 0. So find the time for one full respiratory cycle. So what we want to do is find the period. They're asking for the period. So our period is 2 pi over b, because this is a sine curve. And we know that the value of b is the value right in front of t right here, pi over 3. So to find the period, it's 2 pi divided by pi divided by 3. When you divide by a fraction, you want to multiply by the reciprocal. So 2 pi over 1 times 3 over pi. The pi's will cancel. So one full respiratory cycle is happening at the value of 6. Find the number of cycles per minute. Well, there's 60 seconds in a minute, and we know that one cycle takes 6 seconds. So that gives us 10 cycles per minute. This model is for a person at rest. How might it change for a person that is exercising? So if you're exercising, you're going to be breathing at a faster rate. So the period, the breathing cycle, is going to be shorter. Okay, and last problem. Lena is on a swing thinking about trigonometry. You can tell I made this problem up. She realizes that her height above the ground is a periodic function of time that can be modeled by a given function. It's a cosine function, where t represents time in seconds. How high above the ground is Lena after 1 minute of swinging? All right, so we know that then that means that t has to be equal to 60 seconds because time is in seconds and they're asking for 1 minute. All right, so we want to put in 60 into our function. We're going to use our calculator to do that. We're going to store 60 into x, and then we'll type the function. We already know we're in radians because of the previous problem. And we get a value of 8. So she would be 8 feet above the ground. What is Lena's range of heights? Now, this looks like it could be kind of a tricky question if you're thinking you have to sketch the whole graph, but all we really care about is finding the minimum and the maximum values. So let's just kind of start to sketch the curve. We know that our x-axis is time in seconds, and our y-axis is the height in feet. We know that our center of our curve is happening at 5 right here because we know we have a vertical translation of 5. And we know that our amplitude is 3 because the value of A is 3. So we know our distance from the center is 3. So we're going to go up 3 to 8 and down 3 to 2. So the range of heights is happening from 2 to 8. And that's really all we need to sketch to know the answer to this problem. So the height is going to be less than or equal to 8 and greater than or equal to 2. All right, that's it for this lesson, everyone. I hope you enjoyed it. Have a great day.